In this video, we are going to discuss number of atoms in unit cell and the crystal system. As I told you, there are four types of unit cells: primitive or simple unit cell, body centered unit cell, face centered unit cell, and end centered unit cell. Now, number of atoms present in primitive or simple unit cell. In case of simple unit cell, constituent particles occupy 8 corners and contribution of corner atom within the unit cell, it is 1/8. The distance between centers of two spheres, it is edge length, that is A, and say R is the radius of the sphere or atom. Now, as I said, there are 8 corners and contribution of corner atom is 1/8 within the unit cell, and therefore total number of atoms present in primitive or simple unit cell, it is equal to 8 into 1/8, that is equal to 1. So there are 8 corners and therefore 8 into 1/8, contribution of each atom within the unit cell is 1/8. So 8 into 1/8, it is equal to 1. So remember, in simple unit cell there is one atom within the unit cell. Now, number of atoms present in body centered unit cell. In case of body centered unit cell, constituent particles occupy 8 corners and the center of unit cell. Now, contribution of corner atom is 1/8 and contribution of center atom or the atom which is present within the unit cell, contribution of that atom is 1, because entire atom it is present in the unit cell. So total number of atoms present in the body centered unit cell, it will be 8 into 1/8. This is for corner atoms. So this is 1 plus 1. Actually this 1, this is the contribution of the atom present within the unit cell. So 1 plus 1, that is equal to 2. It means in body centered unit cell there are 2 atoms. Now, number of atoms present in face centered unit cell. In case of face centered unit cell, constituent particles or atoms occupies 8 corners of the unit cell, and there are atoms at the centers of 6 faces. Contribution of corner atom is 1/8 and contribution of face atom within the unit cell, it is 1/2. So total number of atoms, it is equal to 8 into 1/8. This is for corner atoms. There are 8 corners and contribution of corner atom is 1/8. So this is 1 plus 6 into half. There are 6 faces and contribution of face atom is half. So 6 into half, this is 3. So 3 plus 1, it is 4. It means in face centered unit cell, altogether there are 4 atoms. And the number of atoms present in base centered or end centered unit cell. In case of end centered unit cell, constituent particles occupy the corners and there are 2 atoms which occupy the centers of end faces. So this is the end centered unit cell. Total number of atoms. So as there are 8 corners and contribution of corner atom is 1/8. So 8 into 1/8, this is 1 plus 2 into half. There are 2 faces, end faces, at the center of which there are atoms, and contribution of face atom is half. So 2 into half, this is 1. 1 plus 1, that is equal to 2. So in end centered unit cell there are 2 atoms. So this is about the total number of atoms present in various unit cell. You remember, in simple unit cell or primitive unit cell there is 1 atom. In body centered unit cell there are 2 atoms. In face centered unit cell there are 4 atoms, and in end centered unit cell there are 2 atoms. Now next point, that is the crystal system and Bravais lattices. There are 7 crystal systems and 14 Bravais lattices. So on the basis of lattice parameters, different solids may have three possible arrangements. So there are accordingly there are first of all, crystal systems are classified into three different arrangements, like the arrangement where all the edges are same, that is A is equal to B is equal to C. This is one arrangement, one type of arrangement. Another arrangement is there are some crystals where two edges are same but one edge is different. So A is equal to B, not equal to C. This is another arrangement. And third possible arrangement is all the three edges are different. A is not equal to B, which is not equal to C. So these are the three possible arrangements. Accordingly, the crystal systems, first of all, these are classified into three. Now the consider crystal system where A is equal to B is equal to C. Now in this crystal system, now depending upon angles between these three edges, there are two possibilities. One possibility is all the angles are same. When all the angles are same, that is alpha is equal to beta is equal to gamma, which is equal to 90 degree. Such an arrangement, it is called as cubic. Remember, in case of cubic crystal system, A, B, C, all the edges are equal length and all the angles are same and equal to 90 degree. That system is called as cubic crystal system. This is the first system. And cubic crystal system have a three Bravais lattices: simple cubic system, body centered cubic system, and face centered cubic system. Now again, for A is equal to B is equal to C, another possibility is there may be alpha and beta, these two angles are same, that is equal to 90 degree, but gamma is not equal to 90 degree. Now the crystal system with A is equal to B is equal to C, it means all the edges are same and two angles are 90 degree, that is alpha beta are 90 degree, but gamma is not equal to 90 degree. Such a crystal system, it is called as rhombohedral, and it has the only Bravais lattice, that is primitive or simple Bravais lattice. So this is about the A is equal to B is equal to C. Now the crystal system with A is equal to B but not equal to C, this is again further classified into two depending upon the angles. Now first possibility is for this A is equal to B is equal to C, not equal to C crystal system, when all the angles are same, that is alpha is equal to beta is equal to gamma equal to 90 degree, then the crystal system, it is called as tetragonal, which crystallizes into two Bravais lattices, that is primitive and body centered cubic. Another possibility is the crystal system with A is equal to B not equal to C may also have the possibility where two angles are same, that is alpha is equal to beta equal to 90 degree but gamma is equal to 120 degree. Such a system is called as hexagonal. This is the fourth crystal system, it is called as hexagonal crystal system, and it has the only Bravais lattice, that is the primitive or simple. Now consider third possibility, that is all the edges are different. A is not equal to B is not equal to C. For this type of crystal system, there are three possibilities again. First is when all the edges are different and all the three angles are same equal to 90 degree, that is alpha is equal to beta is equal to gamma equal to 90 degree, then the resulting crystal system, it is called as orthorhombic. And orthorhombic crystal system have four Bravais lattices: primitive, body centered, face centered, and end centered. Another possibility for this crystal system with all the three edges are different, the possibility is alpha beta equal to 90 degree, gamma is not equal to 90 degree, or any of these three angles may be different. Such a crystal system, it is called as monoclinic, and monoclinic crystal system has two Bravais lattices, primitive and end centered. And third possibility for A is not equal to B is not equal to C is all the angles may be different. Now the crystal system with all the edges are different and all the angles are different, it is called as triclinic, and it has the only Bravais lattice, that is primitive. So in this way there are 7 crystal systems: cubic, rhombohedral, tetragonal, hexagonal, orthorhombic, monoclinic and triclinic. And there are 14 Bravais lattices, 3 Bravais lattices for cubic, 1 is for rhombohedral, 3 for tetragonal, 2 for tetragonal, this primitive, that is 1 for hexagonal, 4 Bravais lattices for orthorhombic, 2 for monoclinic and 1 for triclinic. Altogether there are 14 Bravais lattices. So just you, for logic, keep in mind, for A is equal to B not equal to C type of crystal system, the ending is gonal, or suffix it is gonal. So gonal, you remember, this is just logic. Then the crystal system, in that crystal system 2 edges are same, 1 edge is different, and when ending is ic, meaning of this is all the 3 edges are different. Now this is the shape of cubic, simple, body centered and face centered. Already I explained examples. Some examples are sodium chloride, potassium chloride, calcium chloride, copper, zinc sulfide, cesium chloride, etc. This is the tetragonal system which crystallizes in simple and body centered. Examples are tin oxide, titania, zirconium silicate. This is the monoclinic system. Already I explained about the parameters. These are the shapes. This is the simple monoclinic, and this is the end centered monoclinic. Examples are copper sulfate, dihydrate, sodium bicarbonate, sodium sulfate, decahydrate, monoclinic sulfur. These are the examples of monoclinic system. Next, orthorhombic. It may have 4 Bravais lattices. Simple, this is body centered, end centered, and this is the face centered. Examples are barium sulfate, potassium nitrate, then magnesium silicate, potassium sulfate, cadmium sulfate and silver bromide. Next system is triclinic. This is the shape of triclinic, and the examples of copper sulfate pentahydrate, sodium bisulfate, then potassium dichromate, then hydrogen phosphide. Next is rhombohedral. These are the lattice parameters, and this is the shape of rhombohedral. Examples are graphite, interhalogen compound of iodine, iodine monochloride, alumina, calcite, arsenic, tin, bismuth, and last hexagonal. These are the lattice parameters, and this is the shape of hexagonal unit cell, and the examples are lead iodide, then magnesium metal, cadmium metal, zinc oxide, boron nitride, then silica SiO2, then mercury sulfide, cadmium sulfide. These are the examples of hexagonal crystal system. So these examples are important for objective type question, and this is about the crystal systems. There are 7 crystal systems and 14 Bravais lattices.